Welcome. Ever really look at the power adapter for your laptop or your phone? You know that little brick that seems so simple? Well, today we're going to crack it open, metaphorically, of course, and uncover the absolutely incredible high-speed magic that's happening inside.
I mean, it's a great question, right? Think about it. This tiny little box takes all that powerful, kind of chaotic electricity from your wall and perfectly transforms it into the stable, precise energy that your super delicate electronics need to survive. How does it do that without being some giant, heavy, old-school transformer? All right, let's get right into it. The answer is all about a piece of technology that totally revolutionized how we handle power. And trust me, it's inside pretty much every modern electronic device you own. So, the big secret is something called a switch mode power supply, or SMPS for short. And you can just forget about those old, heavy, buzzing metal boxes you might be picturing. This thing is a total marvel of modern efficiency.
So, what is it exactly? Well, to put it simply, an SMPS converts power by just switching the electricity on and off at an unbelievable speed. You can almost think of it like a super fast water faucet, right? Turning on and off thousands of times a second to deliver just the right amount of water. This rapid-fire switching is the whole key to making these things small, light, and incredibly efficient.
Now, to really get how this works, we need to meet two key players. First up, we've got the muscle of the operation. This is the part that handles all the raw power and does, the heavy lifting. And that muscle is a power MOSFET. Now, a MOSFET is a type of transistor, but for our purposes, just think of it as the ultimate electronic switch. It has absolutely no moving parts, it's unbelievably strong, and it can flick on and off faster than you can blink. The specific muscle we're going to be looking at today is the 8N80 power MOSFET. It's what's known as an N-channel type, and honestly, its specs are what make it absolutely perfect for this job. First off, just look at the sheer power this tiny component can handle. 800 volts. That is more than enough to take the high voltage coming directly from a wall outlet pretty much anywhere in the world. This little guy is our first line of defense. But it's not just about the voltage. It can also manage a continuous current of 8 amps. That's a serious amount of electrical flow. And it's this combination of high voltage and high current that really gives this component its muscle nickname. But, strength isn't everything. It also needs to be fast. A key feature here is its fast switching speed. That, combined with its super low internal resistance, means it can switch all that power on and off without wasting a bunch of energy as heat. And that is the secret to efficiency. Okay, so we've got our muscle, the 8N80, and it's all ready to do the switching. But brute strength is pretty useless without some intelligence, right? The muscle needs a brain to tell it exactly when to switch, how fast to do it, and, crucially, when to stop. And this is where our second component makes its entrance, the UC3842. It's a special kind of chip called a PWM controller. And in our little story here, this is the brain. And let me tell you, this brain is wicked smart. Its toolkit is just perfect for this. It's optimized for offline converters, which is just a fancy way of saying it's made for wall adapters. It's also got pulse-by-pulse current limiting, which is a vital safety feature that's always watching the muscle to make sure it's not overdoing it. Oh, and look at that last spec, 500 kilohertz operation. We're going to see why that speed is so important in just a minute. What's pretty interesting is that the UC3842 actually has a whole family of related chips. Different versions have different voltage requirements, which makes them good for different jobs. Our guy, the UC3842, with its higher voltage needs, is explicitly designed for these offline applications. In other words, plugging it straight into the wall. So we have the muscle, our 8N80 MOSFET, and we have the brain, our UC3842 controller. Now it's time to see how they team up in this perfectly coordinated, high-speed partnership. And here's the proof that they're a team, pulled right from the brain's own instruction manual. It literally says its output is suitable for driving N-channel MOSFETs. That's our muscle, the 8N80. They are literally made for each other. So here's how this little dance works. The brain, the UC3842, sends out a perfectly timed electrical signal. The muscle, our NN80, gets that signal and bam! Instantly switches on, letting a burst of high-voltage energy flow into a magnetic component. Then, just as fast, the brain cuts the signal. The muscle switches off, and all that energy it just let through gets released at the precise low voltage that your laptop actually needs. And how fast are we talking here? Well, the brain, our UC3842, can orchestrate this whole thing up to 500,000 times every single second. This incredible speed is exactly why a tiny little transformer can do the job of a huge one, and it's why the entire process is so mind-bogglingly efficient.
So, why did we just go on this deep dive into data sheets and electronic components? Well, because this tiny, high-speed partnership has completely changed the world of electronics as we know it. And that brings us all the way back to our original question. This teamwork, this dance between a smart controller and a powerful switch, is the reason you don't have to lug around a 10-pound metal box just to charge your laptop. It's why our chargers are so compact, lightweight, and don't get blazing hot. So let's just recap the whole thing. We've got the muscle, our 8N80 MOSFET, which is the fast and powerful switch. We've got the brain, our UC3842 controller, providing the intelligent, perfectly timed signals. And together, their high-speed dance converts power with unbelievable efficiency, basically making our modern digital lives possible. Kinda makes you wonder, doesn't it? The next time you go to plug in your charger, you'll actually know about the incredible, high-speed ballet happening inside. So what other simple things around you are secretly hiding a whole world of sophisticated technology? What other unsung heroes are powering your world?